Imagine you're on a train moving at half the speed of light. You turn on a flashlight pointing forward. How fast is that light moving? The speed of light, plus half the speed of light, right? Wrong. It's still just the speed of light. Exactly 299,792,458 meters per second. No faster. And that impossibility, that violation of common sense, is one of the most profound discoveries in the history of science. Because light doesn't just move fast. It reveals something shocking about the universe itself. Nothing can beat light. And the reason why will change how you see reality. For most of human history, we didn't even know light had a speed. Aristotle thought it was instantaneous. Galileo tried to measure it with lanterns on distant hills, but his reflexes weren't fast enough. It seemed infinite. Then in 1676, a Danish astronomer named Ole Armer noticed something strange. Jupiter's moons appeared and disappeared behind the planet on a schedule, but the timing kept shifting depending on where Earth was in its orbit. Armer realized light takes time to travel. When Earth was farther from Jupiter, the signal arrived late. He discovered that light moves at a finite speed. Over the next 2 centuries, scientists refined the measurement. But it wasn't until the 1860s that something truly bizarre emerged. James Clerk Maxwell was studying electricity and magnetism, 2 forces that seemed completely unrelated. But when he wrote down the equations describing them, something unexpected fell out. The math predicted waves, electromagnetic waves. And those waves had a speed. When Maxwell calculated it, he froze. It was the speed of light. Light wasn't just light. It was an electromagnetic wave, rippling through space at a fixed speed determined by the laws of electromagnetism. But here's where it got weird. Maxwell's equations gave one number, one speed. They didn't say the speed of light relative to what. They just said the speed. That didn't make sense. Think about sound. Sound moves at about 340 meters per second through air. But that's relative to the air. If you're in a car moving forward and you honk the horn, the sound waves ahead of you move faster relative to the ground. The sound behind you moves slower. Everything works this way. Speeds add, velocities combine. Except, apparently, light. Scientists assumed light must work the same way, that it traveled through some invisible medium, like sound through air. They called it the luminiferous aether, an invisible substance filling all of space. If the aether existed, then Earth moving through it should create an aether wind. And light moving with or against that wind should change speed, just like sound in a moving car. In 1887, Albert Michelson and Edward Morley built an experiment to detect it. They split a beam of light, sent it in 2 perpendicular directions, bounced it back with mirrors, and recombined it. If Earth was moving through the aether, the 2 beams should take slightly different times to return. The light waves should fall out of sync. They measured nothing, no difference. No aether wind. They repeated the experiment, again and again. At different times of year, different orientations, always the same result. Light moved at the same speed in every direction, no matter how Earth was moving. It made no sense. Enter Albert Einstein. In 1905, a 26-year-old patent clerk published a paper that would shatter centuries of assumptions about space and time. Einstein did something radical. Instead of trying to explain why light speed didn't change, he accepted it as a fundamental truth. He built a new theory starting from 2 simple postulates. 1. The laws of physics are the same for everyone moving at constant velocity. 2. The speed of light in a vacuum is the same for everyone, no matter how they're moving. That second one is the kicker. If light always moves at the same speed, regardless of the observer, then something else has to give, and what gives is space and time themselves. Here's the paradox Einstein resolved. You're standing still. I'm on a spaceship flying past you at half the speed of light. We both shine flashlights forward. You measure your light beam 299,792,458 meters per second. I measured my light beam 299,792,458 meters per second. We're moving relative to each other. Our light beams are moving in the same direction. How can we both measure the same speed? Because we're not measuring the same time. We're not measuring the same space. For me on the spaceship, time runs slower. Distances contract. My rulers are shorter. My clocks tick slower. Not because my equipment is broken, but because time and space themselves are different for me than they are for you. This is time dilation. This is a length contraction, and it's not an illusion. It's reality. Let's make this concrete. Imagine you have a twin. You stay on Earth. Your twin boards a spaceship and accelerates to 99% the speed of light, travels to a distant star and comes back. For you, decades pass. For your twin, only a few years pass, you age. Your twin doesn't. Not as much. When they return, you're elderly. They're still young. This isn't science fiction. This is experimentally verified physics. Particles called muons are created high in Earth's atmosphere when cosmic rays strike air molecules. Muons are unstable. They decay in about 2 microseconds at near light speed. They should only travel about 660 meters before decaying. But we detect them at sea level, thousands of meters below where they were created. Why? Because from our perspective, their internal clocks are running slow. Time dilation extends their lifespan. From the muon's perspective, it experiences the usual 2 microseconds, but the distance to the ground is contracted. Length contraction brings the Earth's surface closer. Both perspectives are correct. Both are real. Space and time are not separate. They're woven together into a single fabric spacetime, and the speed of light is the conversion factor between space and time. So why can't anything go faster than light? It's not just a speed limit. It's a structural feature of spacetime itself. Here's the key insight: mass and energy are related. Einstein's famous equation, E equals mc squared, tells us that mass is a form of energy. When you accelerate an object, you give it kinetic energy. The faster it goes, the more energy it has. But as you approach the speed of light, something strange happens. The object's relativistic mass increases. It gets harder and harder to accelerate. You need more and more energy to push it just a little bit faster. At the speed of light, the energy required becomes infinite. You cannot give an object with mass infinite energy. It's impossible. Light itself has no mass. Photons are massless. That's why they travel at the speed of light. It's the only speed they can go. Anything with mass is forever trapped below that limit. But there's something even deeper here. The speed of light isn't really about light. It's about causality. It's the speed at which cause and effect propagate through the universe. If you could send information faster than light, you could send signals backward in time. You could violate causality. You could receive an answer before you ask the question. The universe doesn't allow that. The speed of light is the speed of causality itself. The maximum rate at which one event can influence another. Gravity travels at the speed of light. When two black holes collide billions of light years away, the ripples in space-time gravitational waves spread outward at exactly the speed of light. We've detected them. LIGO and Virgo observatories have measured these waves, confirming once again, nothing propagates faster. Every particle accelerator on Earth confirms this. At CERN, protons are accelerated to 99.99991% the speed of light. Enormous amounts of energy are pumped in, but they never reach light speed. They just get closer and closer, their mass effectively increasing, the energy required skyrocketing. GPS satellites orbiting Earth have to account for relativity. Their clocks run faster than clocks on the ground, because they're in a weaker gravitational field and moving at high speed. If we didn't correct for time dilation, GPS would drift by kilometers every day. Relativity isn't abstract, it's in your phone, and yet light keeps moving. Every photon emitted from every star, every flash of lightning, every LED in your room, traveling at exactly the same speed. A photon doesn't experience time. From its perspective, if it had one, it's emitted and absorbed in the same instant. The journey across the universe happens in zero time. But from our perspective, it takes billions of years. Two perspectives. Both are true. Both parts of the same reality. So here's what we've learned. The speed of light is not arbitrary. It's not just the speed that light happens to go. It's a fundamental constant of the universe. A cosmic speed limit built into the structure of spacetime itself. It tells us that space and time are flexible, that they bend and stretch to preserve the laws of physics for everyone. It tells us that mass and energy are interchangeable, that nothing with mass can reach light speed, and that causality has a maximum speed. It tells us that the universe has rules, deep, elegant, unbreakable rules. And when we look up at the night sky, Every photon that reaches our eyes has traveled at that exact speed, some for seconds, some for billions of years. They all moved at the same rate, the rate that defines how fast information can flow through reality. Light doesn't just illuminate the world, it reveals the hidden architecture of spacetime, and nothing can beat it.